Imagine peering deep into the universe, witnessing the birth of stars, the evolution of galaxies and the potential for life on distant exoplanets. Imagine a powerful telescope to see through the dust of the universe and reveal its secrets. This is the James Webb Space Telescope, JWST, a miracle of human science and the successor to the Hubble Space Telescope. With its advanced infrared capabilities, JWST promises to change our understanding of the universe and reveal secrets that have been hidden for billions of years. Join us as we explore the journey of this amazing telescope from its beginnings to its discoveries and discover how everything changed. The James Webb Space Telescope, JWST, is not only larger than its predecessor, the Hubble Space Telescope, but it is also equipped with advanced instruments designed to study the universe in unprecedented detail. One of its key capabilities is its ability to observe in the infrared spectrum, allowing it to peer through cosmic dust clouds and observe objects hidden from traditional optical telescopes. This capability is crucial for studying the formation of stars and galaxies, as well as for detecting and characterizing exoplanets. Unlike Hubble, which primarily observes invisible and ultraviolet light, JWST's suite of instruments includes the near-infrared camera, NIRCam, the near-infrared spectrograph, NIRSpec, and the mid-infrared instrument, MIRI. These instruments cover a broad range of infrared wavelengths, enabling scientists to study a wide variety of astronomical phenomena, from the earliest galaxies in the universe to the atmospheres of exoplanets. One of the most exciting things about JWST is its ability to study exoplanets, planets orbiting stars outside our solar system. By observing these distant worlds in infrared light, JWST will be able to analyze their atmospheres for signs of life and habitability. This includes identifying molecules such as water vapor, carbon dioxide and methane that are essential to support life as we know it. JWST's ability to study exoplanets goes beyond mere observation. Its ability to focus and resolve images allows scientists to analyze the chemical composition of the atmospheres of exoplanets in great detail and to explain their formation and evolution. This information is important for understanding the diversity of planetary systems in our galaxy and beyond. Another important goal of the James Webb Space Telescope is to discover the mysteries behind the origin of the universe. By studying the first galaxies to appear in the universe, JWST aims to explain the evolution of galaxies from their initial formation to the present day. Its infrared capabilities are ideal for observing these distant galaxies whose light has shifted to longer wavelengths due to the expansion of the universe. Deep field observations, such as Hubble's famous Very Deep Field, capture images of some of the faintest and most distant galaxies ever discovered. These observations provide astronomers with valuable data about the formation of galaxies and the processes that have driven their evolution over billions of years. In addition to studying galaxies, JWST is poised to revolutionize our understanding of star and planet formation. Dense regions of gas and dust called molecular clouds are the birthplaces of stars and planets. JWST's infrared vision allows it to peer through these dust barriers and observe the processes that lead to the formation of new stars and planetary systems. The telescope's ability to see fine detail in these stellar regions allows astronomers to study the dynamics of the gas and dust as they collapse to form stars. JWST also observes protoplanetary disks, clouds of gas and dust around young stars from which planets are born. By studying these disks in infrared light, JWST can detect signs of planet formation and reveal the architecture of planetary systems, including extrasolar systems. Beyond its primary scientific goals, the James Webb Space Telescope helps us understand two aspects of the dark universe: dark matter and dark energy. Dark matter is thought to make up most of the universe's mass, but it does not emit light and interacts weakly with normal matter and radiation. On the other hand, it is believed that dark energy is responsible for the acceleration of the universe. Although JWST was not designed to directly detect dark matter or dark energy, its observations of distant galaxies and their distribution across the universe provide important clues to these mysterious phenomena. By mapping the distribution of galaxies and studying their motion over time, astronomers can determine the nature of dark matter and its effect on the larger structure of the universe. Likewise, JWST's observations of distant supernovae and other cosmic phenomena are helping to refine models of dark energy and its role in the universe's expansion. The development and construction of the James Webb Space Telescope is a joint effort between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. ESA provided the Ariane 5 rocket with scientific equipment and expertise, while CSA provided a high-sensitivity sensor, FGS, necessary to identify and stabilize the telescope during observation. International partnerships like this are essential to large space missions like JWST, as they pool resources, expertise, and science objectives. The world's scientific community eagerly awaits the launch of JWST, which is now ready to use its unique capabilities to make groundbreaking discoveries in astronomy and astrophysics. The James Webb Space Telescope is not only a scientific achievement, but also an inspiration for generations of scientists, engineers, and astronomers. Its exciting missions and technological innovation capture the imagination of people around the world, offering new opportunities for exploration and discovery. JWST's educational programs, developed in collaboration with educational institutions and scientific centers, aim to introduce students and the public to the excitement of space exploration. These programs include course materials, educational resources, and interactive activities that reflect JWST's goals and accomplishments. By promoting interest in STEM, science, technology, engineering, and mathematics fields, JWST's development efforts help cultivate a scientific workforce ready to meet the challenges of the future. All these features combine to present a unique view of the world. The James Webb Space Telescope promises to provide the most detailed images of the universe yet. The journey to this location began after the telescope was first conceived in 1996, when a group of scientists and experts from the public and private sectors considered whether NASA could build the telescope. Each group determined that the telescope could be built, and in 1997 NASA agreed to provide research funding to develop the technical and financial requirements. In 2002, the agency appointed a team to build the telescope's main instrument, and created a team of scientists to help with the design process. That same year, the telescope was named the James Webb Space Telescope in honor of the former NASA administrator who was instrumental in the development of the Apollo program. When engineers and scientists began building JWST in 2004, new technologies and techniques had to be developed to meet the needs of the mission. Unlike Hubble, which can be launched and recharged from Earth, JWST must operate independently and is not capable of repair missions. Despite these challenges, the team completed all 18 mirror units and submitted them to rigorous tests to meet the standards required for field work. The James Webb Space Telescope was assembled and tested between 2012 and 2013, with different parts made in different parts of the world. The construction of the solar shield, which protects the telescope from excessive heat and allows it to work efficiently in space, began in 2013. In the following years, the instrument was released JWST to altitude and vibration tests. 18 individual mirrors were made. Carefully examined. Was investigated. It is mounted on the back plate of the telescope. These components were assembled and tested in 2017 at NASA's Johnson Space Center in Houston, Texas. The telescope and its equipment were also tested in the environment in a large thermal vacuum chamber to ensure proper operation in space. The James Webb Space Telescope was launched into Earth orbit on December 25, 2021 at 7:20 a.m. Eastern Time. How does this magnifying glass work? People often compare the sound to spaceflight, but when you first hear it, it's like another camera. However, JWST is common. A powerful space telescope designed to observe objects in space that are too cold or too faint for traditional telescopes, objects such as stars, galaxies, and planets. JWST was designed to capture the infrared light emitted by these distant objects. This way we can study them in great detail. Infrared light cannot easily penetrate air, and these objects appear dark to our eyes. However, JWST can detect not only ultraviolet and visible light, but also infrared radiation. It can image objects covered by dust and atmosphere, improving our perspective on distant world events. Infrared light is also important for studying the physical properties of objects in space, such as their chemical composition and temperature. It can show the shapes and structures of stars, galaxies and other celestial bodies and how they evolve over time. Infrared light is also used to detect signs of chemical pollution in the environment. JWST has multiple mirrors, advanced imaging systems and thermal management technologies that allow it to operate in harsh environmental conditions. Since the telescope is designed to work independently in space, it must be built to withstand challenges and cannot be repaired. This amazing piece of technology is a testament to man's ingenuity and desire to explore the world.